Hey guys, Lard here, and this is the first tutorial of the slicing mesh that I promised you guys. And so in the previous video I showed kind of result we could get, and of course there are issues. As you guys pointed out, we still have our particles flowing into the air and everything, or floating rather. But other than that, this is a perfectly fine level geometry that you could go ahead and use for, I don't know, bullets and even walking on it. So like there are a lot of things that you could actually achieve with this kind of approach. And so let's talk about how we are actually going to do this. So we're not going to use my wall. I'll just keep it in the project for reference, and we'll make our own from scratch. First thing we're going to do, let's go to the Lightsaber and disable the portion of the code that I already wrote, and we will make it with you guys once again. So in the Lightsaber, from the previous tutorials, we have a tick event which goes around doing line trace and then spawns a couple of emitters on hit. So we just keep it like this, and now we're not gonna slice anything yet. So let's create our own sliceable wall. And of course it doesn't have to be a wall, it can be any geometry, but I'm gonna show you the wall because it's one of the simplest concepts to kind of talk about. So sliceable wall, it's a blueprint which extends actor. So we go in and let's add a new component to it, and it will be a procedural mesh component. Oops, I think I did post-proc. Procedural mesh components. Alright, and let's carry it, drag and drop it to the root to make it a new root, which will be useful for us. Okay, and here one thing you want to remember is to disable use complex as simple collision. This will cause us problems if we keep it on. And now let's play and create some geometry here. So the way how procedural mesh works is it allows you to actually have full control over the geometry of the mesh in the runtime. So you can actually specify vertices, surface normals, and all kinds of basically data to create new geometry on the fly. And what we need to do is we need to supply it first and foremost the array of vertices. And let's talk what are vertices. So we go and find our one of the simplest shapes, shape cube. So here we have a button to toggle on the vertices. So you can see that the cube consists of 9 vertices on each of its 6 surfaces. So if I go ahead, place it on the level, and here I press Alt-2 to go into wireframe. Now you will see that the cube consists of triangles, and these triangles is what we call polygons in computer graphics. And these polygons are connected to each other with vertices. So you can see that all these polygons, all these triangles, they are sharing quite a lot of vertices. And this is useful for us because we can basically have the same coordinates when we're creating vertices to create surfaces. Okay, so how does this help us? Well, let's create at least one surface procedurally. So we have our proc mesh. Let's get it here and let's write procedural mesh to get all the possible functions that we can use. And we need to create mesh section. So this is basically how we add geometry to the procedural mesh. We add sections. So we don't need stuff necessarily, we don't need stuff like UVs, vertex color tangents. What we do have to supply to it is vertices and triangles. And triangles are basically the index buffer array. And I'm not going to go too deeply into how these are used in the computer graphics. Honestly, I don't even remember from my HLSL and JLSL days, basically. But for now, let's make at least one polygon, one triangle. So I did make array for triangles, so this index buffer, and make array for vertices as well. And again, the polygon is one triangle, so we need 3 points to create a triangle. And these points are in the local space of this blueprint. So let's make the triangle 1 meter. Or two of its smaller sides will be 1 meter long. So I start with 0, 0, 0. This is the first coordinate. And then let's do 0, 0, but then 100. So it will be 1 meter higher. So first point is 0, 0, 0. Second is 0, 0, 100. And so I went from here to here. Now to finish up our triangle, I will add another point, which will be 0, 100. Well, actually, yeah, it can actually be like 100, 0, 0 also. So let's do that. So 0, 0, 0, 0, 0, 100, and then let's do 100, 0, 0. And we can do this once again. We're doing this in the construction script, so this is fine. And let's see if we get anything here. I think we don't, because I messed up the vertices. So okay, I think we should do. Let's see. Yeah, this will be a little bit harder. So let's do something that clearly works at least. Let's not create collision. We don't need normals. Yeah, so it's all fine. We just need to supply proper coordinates. So let's do 100, 0, 0, 0, 100, 0, 0, and then 100 and 100 and then 0. So now if we look below, one problem that can be happening is that I'm not sure where the camera is. So reset camera. That's a good thing. This thing exists here, and we still don't see anything. So let's see, what did we mess up? So we added one triangle. We don't need normals, right? So actually I messed up the index array. So it's just, don't think too much about index array for now. It's just, you know, put there the same indices as the index of the elements. So actually that was the problem. Okay, so now if we look below, we can see our guy right there. So we made one polygon procedurally, which is great. Now if you want to make another one, you just add 3 more points. Remember, you have to specify all 3 points for each of the polygons. So I had 0, 0, 0, 100, 0, 0, 100, 100, 0. So now I will also start from the same place, which is 0, 0, 0. And let's say if this was this point, this point, this point, now we had like I went up and went right. So now from the 0 point I need to go right, and then I go up. So the first point is 0, 0, 0. The second point will be 0, 100, 0, and the third point once again will be 100, 100, 0. So we're sharing 2 vertices, but we still need to mention them. And now we have 6 vertices. We need to supply same amount of these guys, which are index buffer. So 0, 1, 3, 4, 5. Exactly what we need. And I think I messed up the order, so we're not getting anything. And if we look up, yeah, we see that we see the vertex on top. So it's basically it's facing the wrong direction, and the reason for this is because the order in which you mention these points is important. It actually affects the direction of the surface. So I do it this way. First we go to 100, 100, then we go 0, 100. And now you can see we get a full surface. So now you would ask me, well, this is just one surface and we did 6 points, right? So we need much more points because we need 6 surfaces to create a cube. Well, thankfully, Unreal API has a solution for this kind of problem. And this is generate box mesh. Now generate box mesh does not do anything by itself. It doesn't generate any geometry. It only computes and gives us as a result all the nice information that we need: vertices, triangles, normals, UVs, and tangents. So only thing we need to supply to it is box radius. So this is box extent. So let's put 1 meter by 1 meter by 1 meter there. And now, oh, look at that, we have a box. Perfect. Let's just drop it straight into the game. So I find my mesh here and I put it here. And let's play the game. So as you can see, it works. Visually, though, there's no collision. So let's fix this part. Let's add a collision. So one thing you can do, if you're not gonna, if you are using procedural meshes without slicing them, you can just go ahead and say use complex as simple collision, return this checkbox to true, and then we need to make sure that we check this one, this mark, and we have a collision. And as you can see, you can actually like get your effects of a lightsaber collision or lightsaber trace on it. Now, if this thing is not checked, let's see if we still get the collision. Yeah, we don't. So we need to have this thing unchecked for our slicing purposes, because if you have it checked, actually when you slice the mesh, you will lose all the collision. So we have to have it unchecked and create collision manually. Now to create the collision manually, you only need the same vertices that you used to create the mesh section. You just need to say add collision convex mesh and put the same vertices that you used to create a geometry, and they will be used to create a collision for the geometry. Just like that. Boom. So it works. Okay. So now let's slice this thing. And well, what would be the simple way to do it? Well, here you can see if I went back to my lightsaber, I have a line trace, and line trace detects all the collision hits. Well, this hit result gives us a lot of information, including what kind of actor was hit and what kind of component was hit. And this information is all interesting. And you could check what kind of component was hit and check if it's a procedural component. But in our case, sliceable wall only consists of a procedural mesh component. So if we hit sliceable wall, the only possible component that could be hit is this guy, right? So we could just go ahead and say, well, if the hit actor is castable to sliceable wall, right? Then we definitely hit a procedural mesh component. So we could just say, well, hit components, well, or either, you know, the successful cast would give us sliceable wall, so we can say get proc mesh, which is exactly the component that was hit. So you could also take it from here and cast a procedural mesh, or you could do this. And then there is a handy function called slice. So plane position, let's give it our hit location, and as a plane normal, let's give it 0, 0, -1. And -1 will basically make a horizontal slice. It's not 1 because if you put 1, then it slices the bottom part, and it's, you know, it doesn't make sense. Usually, you know, you slice the top part and the bottom part remains on the floor, right? So without doing any other things here, let's see what happens if we just keep it like that. Oh, so it works, but you can see there is geometry, just, you know, you can now see through the box. And the reason for this is because we are not putting any new geometry on as a cap to this slice box. So let's just do that. And create, we can use last section for cap, right? So cap material, and this is where it gets really funny, because you can just go ahead and say, well, how about I pretend that this is like lightsaber plasma burn, and because, you know, plasma burns through the whatever material this is, it's kind of leaves this glowing surface, which was just freshly sliced off with a really hot ray of plasma, right? So you go ahead and boom, look at this. Okay, so this works. One thing that we don't like is that the surface material was not actually applied properly, so let's see what happens there. I think it's because I use less section for cap. So let's create a new section. I think that's the reason. Yeah, so when you create a new section, you can actually give it the material, just like I said. And you can see that we're slicing and we get a nice collision. Okay, so we are already getting some particle effects issues and so on and so forth. For now, let's just stop this tutorial, and we will talk about slicing in the proper direction in the next one, as well as maybe some other nice tweaks that you saw already being applied in for this wall. Okay, thank you for watching, guys, and see you next video. Bye bye.